Would you like to keep an eye on your home or office while you're away? You don't want to spend a lot of money? Then stick around. We'll show you how to make a security camera that sends a photo to the Discord every time it detects motion, all for less than $10. All of that and more on today's episode of Will Makes TV. Hello and welcome back to Will Makes TV. I'm your host Will, and today we're going to make a Discord security camera. A small DIY camera that you can build for less than $10, and every time it detects motion, it'll take a picture and send it to Discord, any channel that you choose. And since it's Discord, if you have the app installed on your phone, all notifications will get sent there too. For this build, we'll be using an ESP32 cam development board and a passive infrared sensor to detect motion. And all of this will be housed in a custom 3D printed enclosure that we could use to either mount to the wall or the ceiling. Here's a quick look at all of the parts we're going to be using for this video. A breadboard, some jump wire, an Arduino Nano, an external wireless antenna, 5.5 by 2.1 millimeter DC power jack, ESP32 cam development module, a passive infrared or PIR sensor, a 5-volt power supply, some extra wire, and a Dupont connector kit to build our wires. We'll first want to connect the ESP32 cam to the Arduino and set it into flash mode. If you're not familiar with how to do this, pause here and check out our video on how to flash an ESP32 using an Arduino. Then we'll need to connect our PIR sensor to the breadboard using jump wire, we'll connect it to the 5 volts, ground, and GPIO 15. With our sensor connected, we can then go to the Discord SpyCam GitHub repository to download the project code. We'll also need to download the HTTPS for Makers project for the cert to ESP32 Python script. And since we're using a Python script, you'll also need to install Python if it's not already installed. Links to both repos can be found in the video description. To generate an SSL certificate, we'll need to visit discord.com. From the address bar, click the lock and then select Certificate. Select the Details tab, then select Copy to File. Click Next, then select the Base64 encoded option. On the next step, select the extracted folder of the HTTPS for Makers download and give it a name. Let's just call it Discord Cert. If everything worked as expected, then you should see a message that the export was successful. We'll now want to edit the cert to ESP32 Python script for the HTTPS for Makers project. We'll update it to use our file name. Once we've saved the script, using command prompt or terminal, change to the directory for the HTTPS for Makers project, and then run the cert to ESP32 script. This will format our certificate in a way that we could use with the ESP32. Now we'll open the Discord spycam.ino file. And we'll update the secrets file with our formatted certificate. Also be sure to update the Wi-Fi name and password. And last, we'll go to our Discord, right-click the channel, and then click Edit Channel. From the Edit menu, select Integrations and create a webhook to create a bot. Give the bot a name and optionally upload a photo. Paste in the webhook URL and remove the domain name. Now we're ready to compile and upload to the ESP32. If everything is working as expected, then we should see a photo posted to Discord when motion is detected. Now that we have a working circuit, we'll want to start building the case and wiring harness to connect everything together. We'll start off by cutting some wires to use for our power jack. We can tell which side is power by connecting the power jack to the power supply and then using a meter to test the voltage. Now that we know which side is which, we can solder the wires. We'll tin the wires and solder them to the leads on the power jack. With our power jack soldered, we can now build out the remaining wires. We'll need to cut 2 wires for power, 2 for ground, and 1 for data. We'll then group the wires together with the 5-volt power, data, and ground for the sensor, and a separate group for power and ground for the ESP32. Both groups will then need to be soldered to the wires on the power jack. We'll use our Dupont connector kit to add connectors to the end of the wires. This will make it easier to connect the wires to the PIR sensor and the ESP32. We'll use a 3-barrel connector for the PIR sensor, a 2-barrel connector to power the ESP32, and a single barrel connector to connect the sensor to GPIO 15 on the ESP32 cam. We will then strip and crimp the ends of the wires. The crimped ends will slide into the barrels of the Dupont connectors and lock into place. We'll then turn to our 3D printer to print a wall-mounted case. Once the case is printed, we'll start by sliding in and securing the DC power jack. And adding a couple of pieces of heat shrink tube for later. We'll then need to strip the wires and twist and solder to complete the circuit. Once we've soldered the wires, we can slide down our heat shrink tube and then light it up. Last, we'll add our external Wi-Fi antenna to give our camera a bit more range. With our wiring complete, we are ready to connect the ESP32 cam and the PIR sensor, and then stuff it all inside the box. Be sure to adjust the sensitivity and the time delay on the PIR sensor before mounting it inside the case. Use the snap fit lid to align everything and we should be good to go. We also have a ceiling mounted model that uses parts from a cheap dummy camera found from Amazon. From the dummy camera, we'll use the clear plastic globe, the camera shroud, and the fastening screws. We'll need to first glue the camera shroud to the clear globe. Be careful to only use a little bit of glue. We'll then need to align the hole for the DC power jack to the back of the camera shroud. The power jack is slightly larger than the hole used for the external Wi-Fi antenna. Once we have our alignment down, we can then hot glue the shroud and the globe to the outside of the 3D printed ring. After giving the parts a few minutes to dry, we can take a completed wiring harness, a soldered power jack and all, and slide it through the hole for the power jack. Wait to connect the 3-barrel Dupont connector until after you have screwed the washer to secure the power jack. After connecting the remaining wires for the PIR sensor, you can then add the external Wi-Fi antenna. We can now connect the ESP32 cam and the PIR sensor. Again, using the snap fit lid to align and secure the parts within the case. Then all we have to do is screw on the dome. Finally, we'll want to screw in the Wi-Fi antenna. And now we're all set. Now all that's left to do is to set it up. I'm using a little bit of hot glue for the wall mounted model. And some double-sided tape for the ceiling mount.